This is the video for 3.3a, Congruence and Similarity. In previous lessons you should have got to grips with the two words congruent and similar when we're talking about shapes. Congruent shapes are exactly the same size, so they have equal sides. So the two shapes could be rotations or they could be reflections of each other, and similar shapes could be rotations and reflections but have to be enlargements as well. So there is some sort of scale factor between the shapes, or as they say here, a proportion between the size of the sides. In the first example, we need to try and prove whether these two triangles are congruent or not. So I can rotate things around. I've redrawn the second triangle. If I rotate this triangle, so they're in the same orientation, we now have the lining up of these two equal sized sides. So these are both isosceles triangles where 6 centimeters is here and 6 centimeters is here. Now what we've got is that all three of these sides are now 6 centimeters, meaning that it should be an equilateral triangle, except that the angle at the top is 40 and this angle here is 100. And we should know that equilateral triangles have 60 degrees on the inside, so that shows that these are not congruent triangles. In the second example, we first need to show that triangles ABE, which is this triangle, is similar to triangle ACE, which is the whole triangle. Since we are missing quite a lot of information about the length of the sides, we're going to use the angle trick to do this one. So if all of the angles match in both of the triangles, then they are similar triangles. First off, both triangles share the same angle at the top, this one. Secondly, this angle and this angle are corresponding angles because we have parallel lines along the bottom, so they have to be the same as well. Similarly, this angle and this angle are corresponding as well for the same reason. We've got parallel lines along the bottom, so this angle is copied up here. So all three angles of the triangles are the same, so we must have congruent or similar triangles. The triangles are not congruent because AB is the side of one, whereas AC is the side of the other. So they're not the same size sides, so we must have similar triangles. For part B, we need to find the value of x, and that is the length all the way across the bottom. To do this, we just need to find the scale factors between the triangles, and we're going to do that by comparing the side lengths, and the only information we've got uses these two bits here. So AB is 3 centimeters, which is the side length of the first triangle, but AC is the side length of the other triangle, which is 6 centimeters. One side length is 3, the other side length is 6. They're the two that match together, so the scale factor is 2, which means that all the side lengths are doubled. So if I knew this one, we would double it to get the entire side here. I know this one, so to double it, I will therefore get 8 as x. When you start having a go at the questions, make sure you draw out as many triangles as you need to, flip them round, rotate them, so that you get a clear picture of what's going on. Question 1, you need to label all of the congruent triangles. Use the labeling process of the corners to label them. So for example, BCE is the same as BEA. 2, 3 and 4 require you to prove two things are congruent, like example 1. just draw out the triangles in different ways round to have a look at that. Question 5 needs you to do a similar thing but with rectangle. Question 6 needs this idea from example 2. Questions 7 and 8 require you to think about scale factors. And question 9 is a bit of an example to think about zooming in and zooming out on shapes.